Happy Easter, Grandpa.
Hey, happy Easter, Tyler. I haven't seen you in so long. How you been?
I'm good. How are you?
I'm good. Can you believe what they're telling us on the TV? That climate change is causing sea level rise? Oh, I just think it's another ploy from the government to take our money away. What do you think? You know?
Actually, Grandpa, I can't believe this. It's what I've been studying this past semester. Climate change is actually a real thing, and sea level rise is a real thing that is a real concern locally as well as globally. If you want, I have a PowerPoint that I was working on for a class. I could show you it, and maybe I could change your mind.
Oh, you're gonna make me believe the nonsense, huh?
I'm gonna try. I'm definitely gonna try.
Okay, all right.
Presentation I've been working on with my class. It's about sea level rise and how it affects mainly the East Coast.
Wow, I love the imagery.
Hope so. So, how does climate change actually contribute to sea level rise? I'm sure that's the biggest question on your mind. Sea level rise, or SLR, is easily referred to as governed by the thermal expansion and the melting of ice mass in areas such as Greenland and in Antarctica. It actually has two different types. So there's eustatic and there's isostatic. Eustatic is just the thermal expansion of the glaciers and the ice mass on the global scale. So basically the ice and the water is essentially expanding. The isostatic is changes in the Earth's crust in response to ice mass distribution at a regional level. So when there's like a large ice mass in the center of like a block of land, it starts to sink, the land starts to sink, and the land around it starts to rise. And vice versa, as that ice starts to melt, that land comes down and it comes back to a flat, level plain. The remainders contribute to the melting of the polar ice caps and alpine glaciers. Thermal expansion occurs when the ocean acts as a giant buffer zone for global warming. I have another slide next that I can actually explain that better for you.
Wow.
So this is what I was saying about like the ocean is actually a giant buffer zone, right? So the sun comes down and heats the earth. The water absorbs the majority of the sun rays that's coming down, and as the ocean circulates with what's called gyres, it circulates around and it heats up the water. As the warm water comes back around to the ice caps, melts the ice, water falls in, adds more water, continues the circulation around, and keeps warming and then melting more of the ice cap as a negative feedback loop. So this figure shows a simple explanation of the hydrologic cycle and why the ocean and the glacier combined can accelerate the melting of the ice caps. It's a negative feedback loop, water is warmed and circulates back to the melting ice, falling into the ocean. Any questions so far?
No questions. This is very interesting.
Good. So sea level rise broken down. As I said before, a warming climate causes sea levels to rise and expand over land masses. The melting of ice mass over land mass adds water to the oceans as well. Sea level rise is not uniform across the globe. Coastal communities are impacted more so by the local sea level rise. Local sea level rise is affected by the global sea level rise, but also by local land motions and the effects of tides, currents, and winds. So as the water expands through thermal expansion and the ice melts and more water falls in, the water level overall will start to rise. It may not be much at first, a few millimeters at first, but then over a grand scale, it accounts for so much more water over that you start to cause nuisance flooding, and the local lands like the bottom of Florida or in New London, Connecticut, or in Boston, those areas that are right on the water level start to go underwater as those little millimeters start to add up as more ice starts to fall in. So here you can see the sea level rise is combined with the local air temperature. As the air temperature warms, so does the water. And then as the ice caps start to warm from the air temperature and the water, more water starts to fall in. You see melting ice is 52%, warmer oceans is 38%, and it contributes to global sea level rise from 1972 to 2008. So you can see the heat trapping gases from human activity have increased global average temperatures by 1.4 degrees since the 1880s.
Oh my God, has this been happening all my life?
Yeah, actually it has. Here, I'll show you on this slide. So sea levels in the 600-mile stretch from North Carolina to Boston have climbed on average from 2 millimeters to 3.8 millimeters a year between 1950 and 2009. So yeah, this has been happening all your life. Can you believe it?
I find it hard to believe, but I'm getting there.
So here you can see more places where it's changed. In Boston, Massachusetts, it's risen 6 inches from 1963 to 2012. This graph shows the local East Coast sea level rise over the past 50 years. So again, this has definitely been happening since you've been alive, Grandpa. New York City, 7 inches. Washington, D.C., 7 inches. Norfolk, Virginia, 10.5 inches. Key West, Florida, 5.5 inches. These are all real numbers and how much the water has actually come up over what it used to be.
Hey, what does this even mean for me? What does this mean for where I live?
I'll tell you. So the effects of sea level rise on the East Coast currently. So increased flooding of low elevation lands such as coastal cities, islands, tidal wetlands. 500-year flood zones are becoming 100-year flood zones, and nuisance flooding is now 300% to 900% more frequent than it was 50 years ago. So what all that means is that coastal cities, like all the low-lying places, like I said, in Florida, Miami, New London, all those are going to start to have what's called nuisance flooding. 300% to 900% more frequent, meaning it's going to happen. Nuisance flooding isn't just getting your ankles wet. It's the water coming up and destroying properties, destroying businesses. People have to up and move and relocate. 500-year flood zones are becoming 100-year flood zones. So a bad flood that would happen once every 500 years is now going to happen most likely once every 100 years. One bad flood every 100 years was bad enough. 500 years is terrible. Now the 500-year flood is now possibly going to happen every 100 years.
Oh my God, does that mean I have to build a wall around my house like the border?
You might have to if we don't do something about it. I can tell you about that in a later slide.
Well, since you're gonna tell me about it later, why don't you prove this flooding to me, this increase?
I will, Grandpa. I'm gonna make a believer out of you. So this graph here is showing the average number of flood events every 2 decades since 1950. Now the colors correspond to the years. 1950 and 1969 is the lighter blue. 1970 and 1989 is the orange. 1990 and 2009 is the green. And 2010 and 2015 is the darker blue. Now you can see in Washington, D.C., these lines between 1950 and 1969 and 2010 and 2015. The 2015 line is already over 6 times what it was in 1950. So you can see, just based on this data, the sea level has definitely risen so much more since it was in 1950.
Oh my God, I might be screwed.
It might be. So the effect of sea level rise, if we continue on this trend, meaning business as usual, if we do nothing about our current problem. At its current rate, sea level rise is expected to rise an additional 2.4 to 7.4 feet by 2100 along the northeastern shore. A rise in 1 foot of sea level rise is probable for the year 2050 at our greenhouse gas emission rates. So as I said, it's if we do nothing, and this is a range, the lowest to what it could potentially be by the end of the century.
Oh my God, we gotta stop this. I don't want my house to be underwater.
That's right.
Oh Lord.
So this graph is explaining what I just told you about. This figure shows the projected sea level rise for Boston, Massachusetts. The upper bound of the graph shows that we could see a global rise in sea level of about 8 feet by the year 2100, the end of the century, if we allow our current greenhouse gas emissions to increase. So as you can see, the lowest it could potentially be is about 2.4 feet. The highest it could potentially be is about 7.4 to 8 feet. So this graph is showing the upper bound as well as the lower bound. More than likely, we could be in the middle. If we do something to manage this, we could be down there at the 2.4.
That's what I like to hear. I don't need a boat in the future.
You might need a boat.
Oh no.
Now this is just more illustration to show what it would look like. This is what Boston, Massachusetts, specifically Logan Airport, Logan International Airport would look like with 6 feet underwater. Shows the areas that would become flooded if the sea level did manage to rise 6 feet by the end of the century. The blue areas are underwater, while the green show low-lying areas that are in danger of going under if the level continues to rise. So all of this in the light blue is considered underwater. All the green is potential for going underwater next. You can see that's the airport for Logan International Airport. That would majorly affect international travel, business, shipping. It would dramatically impact everything. So if you haven't seen yet, why is it important? Sea level rise is a major concern to people in Connecticut, New England, as well as the entire planet. As I said, it affects things globally as well as locally, but not all at the same rates. As the Earth warms, it increases the thermal expansion of the water, as explained before. This causes coastal places such as New London, Connecticut, Boston Logan Airport to start to descend below the water level. Coastal towns and cities will have to move and relocate. It's causing businesses to be in trouble, thousands of people to have to relocate, as well as thousands of dollars in property damage, loss, so much else.
What are we gonna do about this?
Well, I'll tell you what we can do about this. Some places like New York City have plans to create levees and bulkheads to combat the rising tides. They have a plan to enact rock breakwaters to break the storm surges offshore. So as those waters are rising in the storm surges, those big waves that are coming in, those rock barriers will catch them and disperse the energy out, so it's less impact on the actual town that's headed towards, as well as other plans specific to the boroughs and their locations of New York. Now, Boston emphasizes community awareness and public education as critical climate combative tools. They aim to educate their population, their citizens, so they're more well prepared. So as a team, the whole of Boston is more well prepared for sea level rise. We can pay to have large stone walls and surge barriers put up for our protection. Some places have like actual barriers in front of their homes if they have a coastal house. However, there are simpler things that we can do as individuals to minimize our carbon footprint. If you do not drive a car, if you don't have to drive, you can simply take a bus, go for a walk, or carpool with your friends. This optimizes the use of the gallon of gas by each person sharing the carbon emissions of it. Don't wait, there's more. Other things that we can do is just make sure that your appliances are energy efficient before purchasing new appliance. Make sure you check the rating. Make sure you check that they are efficient for what they're producing. Shutting off lights when not in use. Use less water. This keeps the energy needed to run the water heater or water pump lower, so you don't use as much energy to run those appliances as well. Keep your thermostat just right and not keep it too high or too low. Now, I know you like to keep your thermostat really warm because you get cold real easily.
Hey, don't judge me, I'm old, okay? Alright?
Well, that's okay, Grandpa, that's okay, but we can get you things like a Snuggie or like a blanket so you don't have to keep your thermostat so high, and that way you'll still be warm but keeping your energy level real low.
Okay.
Other things we can look at is solar energy or driving electric or hybrid vehicles. Now, this isn't just you, Grandpa, this is all of us. This is everything like all of us can do individually. So you can get electric or hybrid vehicles. Driving more conservative, meaning eliminating unnecessary speeding and acceleration. When you're at a red light and the light turns green, don't step on the gas so hard. This just wastes gas and increased carbon output.
Wow. Tyler, you really convinced me here. I really think that the sea level rise stuff is not a joke anymore. It's not a government conspiracy, a ploy from, the EPA, whatever you want to call it. I really think we have to take action and do something about it. I'm really proud. Now, where's my Easter dinner, huh?